talk is entitled 7 Things I've Learned About Cover Crops. I've learned a lot more than that, but 7 just seemed like a good number, so that's what we go with. I like opening up with this slide. It's similar to what Russ said in his talk. So this quote from Emerson I think is very applicable to what we're doing. He says this: the methods there may be a million and then some, but the principles are few. And the man who can grasp the principles can successfully select his own methods. The man who tries methods ignoring the principles is sure to have trouble. So in other words, I can't come in here and tell you exactly how it's going to work on your operation. Russ can't either, Jimmy can't either. But the principles that are working for me in Nebraska and for those guys in Oklahoma, those same principles will work for you here in Missouri. It's up to you guys to figure out what the methods are to apply those principles into practice. So I'm going to show you some of the things that we've learned doing it on our farm. Some of them may apply directly. Some of the methods may be a little different. So number one, I've learned that I'm not smarter than God. Now that comes as a big shock to a lot of people, I'm sure. Did not come to a shock to my wife when she saw this. She said, I knew that. But basically what that means is when we try to farm, we should be looking at how God created these natural systems to work together, because these plant communities and these ecosystems, when we look at how they're working in nature, they work so well together. So what can we learn from the way that these natural and native systems are already working and functioning? First of all, there's great diversity of plants, roots, and animals. You do not see monocultures in nature. That is a foreign concept for a natural native system. There's always much diversity out there. But when you look at our cash cropping systems, it's almost always monoculture. Now there's reasons for that. I'm not saying that we should, plant 15 things all together and try to harvest them. Not saying that, but there are ways that we can get more diversity into our systems without having to grow 40 different crops out there. And again, the best way, I think, is through cover crops, because you can get a tremendous amount of diversity into the system without needing specialized equipment, specialized knowledge, or specialized markets. Because if you're going to grow new cash crops, you need those 3 things a lot of times: a market, knowledge, and equipment. With cover crops, you don't need any of that, but you want to get the diversity out there when you can. So get the diversity. When you have a diversity of plants out there, you will start getting the diversity of roots and animals. And with animals, I'm talking not only the biology, the microbiology like the mycorrhizae here, but you'll be amazed at how much wildlife starts to return to your system as well when you get the right systems in place. Number 2, when we look at natural native communities, we see that the soil was always covered. You don't see bare soil in nature unless it's been messed up somehow. The soil was always covered. And this is what we try to strive for here as well. So this is a picture from about 5 or 6 years ago from our place. I showed this picture in my other slide, or my other presentation. So what this was is we were in the middle of a pretty severe drought. We were already, this picture was, this is the first week in June, and we were already 5 or 6 inches below normal for the year. So very dry conditions. This corn is looking pretty good because, again, this is wheat stubble. I had a cover crop, it winter killed, and we planted into this. We had pretty good moisture here. So these pictures were taken one day, 24 hours after a 1-inch rain in the middle of a really dry period. So my ground soaked everything up, no problems whatsoever. I could have taken a 5-inch, 6-inch rain and soaked it all up. My neighbor, who planted milo, this is corn, but he planted milo. This was, and this guy is probably the heaviest tillage guy in our area. He tilled the heck out of this. And what you see here that looks kind of shiny, that's not water that evaporated and is kind of just moistening. That's water physically standing on the soil yet, 24 hours after a rain. And it's not just on the end rows where he drove a lot, it's all the way down until you get over this hill, and then it probably sprayed into the draw and ran off. But he has such poor infiltration because he had no cover. The raindrop, because that 1-inch rain came in about 10 minutes. That's how it usually happens, right? And the impact of those raindrops exploded the soil surface here, and it just sealed that up tight as could be. And so that water is just physically ponded on there. I'm soaking it all up right there.
What's the population on that corn?
On our dryland corn, we will typically plant about 24 to 25,000 on dryland. Some guys in our area plant 18, 19,000. Our thought is, you know, for the little bit of extra money, it rarely hurts us. Even in a dry year, having 24, 25,000, we don't yield that much less than the guy that planted 18. But if we get a good year and we get some timely rains, it always pays pretty big dividends. So we'll spend a little bit extra money putting the extra population out there. You know, we're planting our irrigated at 32 to 34, and our dry land at about 24 to 25. Okay, the other thing that we notice is that there's always something alive and growing. And again, that's what we want to try to accomplish. We want to mimic the natural system with what we're doing on our farm. We want something alive and growing at all times. So this, I like this picture because this is a radish carcass from the year before. The double disc opener sliced right through that, and there's a corn plant coming right up through that old radish carcass. A little hard to see on this picture. There's snow on the ground up here. So there's snow on the ground, but this soil had never frozen, and you can't see it very well, but there's white living roots. And we also found earthworms. They were not active because it was so cold, but they were certainly there in this, and this is probably taken in January. And then again, we like to do things like this when we can. When we have the combine in the field harvesting, we want to have the planter or the drill out growing the next crop. Now this happened to be irrigated. I think we were planting some double crop cash crops here, but we like to do the same thing with cover crops as well. Get the planter chasing the combine to get every last day that you can for growing. Because when it comes to growing these things, every day in September is worth 2 days in October, and every day in October is worth 2 days in November. So if you miss out on a week of September weather, you didn't just miss out on a week, you missed out on more like 2 weeks of growing time, and it makes a huge difference in how much growth you get on your fall planted cover crops. We also see that plants cooperate and not compete nearly as much in a natural native system, especially in a big diverse mix like this. Because think about it, the most highly competitive plant to a corn plant is not Pomeranian, it's another corn plant. The most competitive thing to any plant is another plant exactly like it growing right next to it, because they want the same thing at the same time, their roots at the same depth, their leaf canopy is at the same height. It's an extraordinarily high competition setting for them. And so when we can spread those out like this, you know, I've got a bean plant here, and I've got millet, and I've got sorghum, I've got all these different things. Their neighbor has different rooting depths, it has different nutrient needs, different water needs, different leaf canopy heights. It's not nearly as competitive in this setting as it is if I planted a monoculture of any one thing. And that's exactly what we see in natural native settings. You don't see monocultures because it's a very bad way to try to grow a plant community because it's super competitive. You always see diverse mixes. And again, I'm not proposing that we can necessarily do that in our cash cropping system, but when you plant a forage crop or a cover crop, or even some people with their silage have been doing multi-species silage, there's some benefit to doing some of these sorts of things. So that's number one. I'm not smarter than God. Number two, I learned that a living soil is a healthy soil and is going to not always, but often lead to higher yields. And so we see this time and time again, that soil biology is the key to unlocking yield potential. And it's not all about yield, it's about profitability. But yield goes into profitability. If you're not having some yield, you're definitely not going to be as profitable as you could be. So the more yield, the more profitability. And cover crops are one of the keys to building better biological life and health. In this carbonomics talk this morning, I talked about all the things that the biology would do, from fixing the nitrogen, which everybody that grows soybeans is very familiar with that one. We're pretty good at that, but it's all of the other things that we kind of fall short on. Having the biology in there to free up the phosphorus and to free up the potassium and to deliver the boron and all those other things that are needed. Those are the biological functions that many of us are missing on our operations because we simply don't have the biology there because of the way that we farmed over the years has been detrimental to it. It does not always mean that cover crops will correlate to higher yields, and you know, I'll be completely honest, we have had times where our cover crops have hurt our cash crops, and a lot of it's because of how we managed it. Perhaps we didn't terminate it soon enough, perhaps we didn't get complete termination. There's a lot of things that can go wrong in planting cover crops. It's not easy to do. It requires higher levels of management, but when done properly and when integrated into your system properly, it will unlock your biology and lead to these higher yield potentials. And so what I tell people is, don't think that you can take the system that you currently have and just stick a cover crop in the middle of it somewhere and do nothing else different and think that that's going to make your system better, because it likely won't. It probably will make it worse. Because by adding these other things, you're adding levels of complexity to your system and to your management, that other things have to be adjusted, whether it's on the timing or whether it's on the the relative maturity lengths of some of your things. There has to be adjustments made as you're doing this. So when done properly, it generally will lead to higher yields, but if the rains just don't come, and there's times when this happens, and Russ can testify to that, Jimmy can testify to that, when a cover crop grows, it uses moisture. It gives you that moisture back by having better infiltration and less evaporation and better water holding capacity. But when the rains don't come to replenish that, it can hurt you. But you know what? There's other things that we do in farming that can hurt you too if things don't go just right. So we like our chances, we like the odds. It gives us greater opportunities for that yield. Number 3 that we've learned is, if you grow it, they will come. Okay, if you grow it, they will come. And again, talking about the biology, oftentimes people ask, so if I don't have much biology in my soil, do I need to go add it? Do I need to dump bugs in a jug? And there are times when that's the appropriate thing to do. There are times when some of these biological additives and amendments can certainly be helpful, but not always will it be helpful. And even if you're putting those on, if you're not giving them the right environment to grow in, you're just wasting your money, because you're going to dump them out there and they're not going to be able to survive. So if you grow it, they will come. If you grow the cover crops, if you have living roots in the soil, putting those liquid carbon root exudates, like that great picture from Jimmy that we saw, pumping all those little droplets of carbon into the soil, the biology will come. Nobody's soil is so depleted that they don't have any biology. Most of our soils are so depleted that we don't have near enough biology. So if we change things and we create the right environment, the biology will come. There are things that you can add to make things come faster. That's a choice, but there are things that can be added to help it come faster. But earthworms and, like what Russ was saying, when I was a kid growing up, if we wanted to go fishing and we wanted to go dig worms, there was one place on our whole farm where we could go do that. And that's right over the hill where the sewer dumped out, no septic tanks back then, it just dumped out. And that was always moist, and you could find worms right there. Nowhere else on the farm could you find an earthworm. I was like Russ, I did not know that earthworms could be in farm ground, because we just never saw them. But now we find them everywhere. And that's just because of how we've changed our farming practices. Again, the soil food web, if you provide the right environment, all of these different things will come, whether it's the small biology or you'll start seeing the wildlife return in a big way as well. We do a lot of work with wildlife habitat people. We've started doing deer food plot mixes and upland game bird mixes, because it's the same thing that we're selling to farmers for cover crops anyway. It's just, packaged just a little bit differently, smaller package types. But there's huge benefits for wildlife with these cover crop mixes. Again, we've already looked at this, but the premise is, if you build the right environment and the biology comes, they'll do great things for you. Again, the mycorrhizae mining the mineral out of the soils. Another picture of the mycorrhizae there. Again, I need to study on this lomalin a lot more. It's been a fairly recent discovery, probably in the last 10 years, that the scientists have really been able to identify this substance. But when you have that, and some of you have probably seen the soil health demonstrations where they'll take the clods and they'll put them in the soil, and you know, the bad soil just kind of falls apart and just dissolves, and the really good soil can set in water forever and stay as a complete piece of soil. It's because it's glued together. These are not going to be dissolved by water. That's why they're so stable and so important. The importance of soil biological life to the health of the soil cannot be overstated. And just because you can't see it doesn't mean it's not important. It doesn't mean it's not there. And frankly, for too many years, the way that we farmed is because we couldn't see it, we just kind of ignored it. And you know, we bought a microscope so we could see some of this. Now, we haven't done enough work studying how to use it properly to really see it. But again, that's why I go back to look at your earthworm population. You can't see the mycorrhizae. You're not going to be able to see the Zotobacter and the Azospirillum and all those little critters. You can see earthworms. And if you see our earthworm populations going up, and you see more and more wormholes, and you see more and more worm activity, you're on the right track. There are some good soil tests. You can send soil in, and you can get a Haney test done. You can get a PLFA test done. There are additional tests coming out all the time that help you identify what biology you have in your soils. If you're interested in those, we can talk more about those later. But again, if you're not seeing significant earthworm activity in your soils, you probably don't have a lot of that other stuff going on as well. Number four, the fourth thing that we learned is you need to mix it up. When we were talking about starting, well, we weren't even talking about starting a cover crop seed company. When we were first talking about using cover crops on our farm, it was 2008. We had heard Ademir Caligari, a scientist from Brazil. He had come over to the Notill on the Plains Conference. He actually came over in 2006, and he was showing us these pictures from Brazil of these guys using these crazy cocktail mixes. That was the first time we'd ever really heard that concept. Prior to that, anybody that was doing a cover crop, well, we just planted sorghum sudan. We planted millet. Even the really out on the edge crazy guys, they were planting radishes. But it was just radishes by themselves, or clover. Maybe you planted clover. The concept and the thought of mixing all of those things together into this crazy combination was really brought to us by Ademir and the successes that they were seeing in Brazil with this. And so when we started talking about doing this, we thought, well, let's give it a try. Gabe Brown and those guys up in North Dakota, Jay Fuhrer, they had started doing some experiments and it had some pretty good success. What we were worried about is, will this use too much of our moisture? Because we were still concerned about the moisture usage, particularly after wheat harvest, because wheat stubble in our area, the thought was is it catches all this moisture. We plant corn into it the next year, and voila, it's automatic 20 to 30 bushel corn boost over continuous corn. And so we didn't want to jeopardize that. So what we saw when we did this, we wrote a little SARE grant. I got like $5,000 or $6,000, and I got moisture probes and moisture sensors. And I had sensors at 1 foot, 2 foot, and 3 foot levels. And we scoured the nation, and we found about 30 different types of cover crops. Peas, veg, lentils, clovers, all the sorghums, millets, brassicas, etc. What we found, and this is very interesting, because we were out there almost several times a week just looking at these plots, because it was all this stuff we'd never seen before, but we were also taking readings on these moisture sensors. Every place that we had a monoculture mix, and it didn't matter if it was sorghum or vetch or radish, every place that we had a cover crop growing in a monoculture setting, it used significantly more water than every place that we had a mix of those same things growing. And it was replicated several different times, and it's been backed up by what Gabe and those guys saw up in North Dakota. It's exactly what Jimmy saw, the slides that Russ was showing there. Because he's growing these things in a mix, because we're growing these things in mixes, they're far more efficient at moisture usage and everything else than when we're growing things in a monoculture. So we want to mix it up. There's great power in diversity. Cover crop benefits, I think this is actually a slide I got from Rob Myers from the University of Missouri here. Cover crops are kind of the Swiss Army knife of agriculture because they're the multifunction tool. All these different things can be accomplished by using cover crops, but not all of them can be accomplished at the same time. So when you're deciding what you want to use for a cover crop, if you call us or you call whoever you're getting cover crop seed from, the first question that we should ask is, what do you want to try to accomplish? Because you can't provide nitrogen through your legumes, and it's difficult to do this one and control weeds, or because some of these, if we're going to produce a lot of nitrogen through legumes, that probably doesn't mean I'm going to have long-lasting residue to control weeds later the next year. So you have to kind of pick the goals that you want to do and then choose the right cover crops to try to accomplish those goals. These are a few slides from Dwayne Beck. Many of you have probably heard Dr. Beck from South Dakota talk, but he says there's great power in diversity. Our natural systems have a huge amount of diversity. Our cropping systems do not. And he says that weeds and diseases are nature's way of adding diversity to a system that lacks diversity. Okay, so Maresdale outbreak in a soybean field right here. Nature's effort to add diversity can be countered by adding beneficial diversity to the system. So rotate your crops, have a wider crop rotation. Don't be like Russ and think that just switching to a different variety of wheat needs a rotation. But hey, let's be honest, we've got people that in my area, yeah, I went from DeKalb corn to Pioneer corn, so I guess I rotated. That's not a rotation. Even corn and soybeans isn't a rotation. It's an oscillation. It's just a back and forth, back and forth. You need to have at least 3 things to be able to rotate. Otherwise, it's just an oscillation. And so having a wider crop rotation can be adding diversity, but also adding cover crops can certainly help that as well. Most farmers find it difficult to get enough diversity in that cash crop rotation, and that's why I said this earlier, cover crops are the great way to do that, because you don't need specialized equipment, specialized markets, or specialized knowledge. It's just being done for you through the soil. And I wanted to show you an example of how we've implemented this on our farm. Again, this may or may not work. I actually think this might work pretty decent down here for you. So what we do is we grow wheat or rye or any type of summer harvested cereal crop. We're a little bit too far north to reliably double crop soybeans. You guys, I'm sure, can do that here all the time. This might be another option for you, though. So rather than double cropping soybeans, because there's a couple problems with double cropping soybeans. Number one, we run out of time because they die with the first frost. Number two, when you harvest soybeans, you're taking everything in the field and running it back through your combine. So all that nice, beautiful wheat stubble residue that's so valuable to us for catching snow and stopping the wind and blocking evaporation, all of that residue gets destroyed because we're running it through the combine with the soybeans. So those were a couple things that we were trying to avoid. So what we did is we're going to double crop sunflowers now instead of soybeans. And sunflowers have some added benefits because they don't form as tight of a canopy. I can now get companion crops to grow down underneath them. Very difficult to do with soybeans, to get anything else to grow with a soybean. And if you could, now it becomes a harvest issue because, again, if you're growing it, you're going to run it through the combine with a soybean. If it's making any seed, it's ending up in the grain tank with your soybeans. So sunflowers gives us those benefits. So we planted hybrid sunflowers, and you plant hybrid sunflowers about the same population that you would corn, so 20 to 30,000. And then we added these other things in: mung beans, chickpeas, vetch, lentils, crimson clover, peas, mustard, cabbage, buckwheat, and flax. We added all of that into the mix. The sunflowers back in this time, this is 5-6 years ago, cost about $1 per 1,000 seeds. So, we had maybe 30 bucks an acre in our sunflower seeds, and 15 to 25 in the covers that we were adding in with this. So here's what it looked like. There's a couple ways to do it. We have done it both ways, but most of the time we just mix them all together, throw them in a drill, and go out and drill the whole thing. You can leave the sunflowers out of this mix, drill your companion crops, and then come back with a corn planter and plant your sunflowers in 30-inch rows. You actually get a little better spacing on your flowers, probably will give you a little bit of a yield bump, but you do have to cover everything twice as well. So it's a little bit of trade-offs there. This is what it looks like when it's coming up. Obviously a lot of sunflowers because it's a full rate of sunflowers. The thing that you see coming here the first is buckwheat. Buckwheat is a beautiful plant. blooms in 30 days. It'll be making seed in 6 weeks, which sometimes isn't so great. But the thing is even when it's making viable seed, it's still blooming like crazy. And so it'll start blooming in 30 days, and it will bloom for 5 to 6 weeks. And it is bringing in all kinds of beneficial insects and predatory insects ahead of when these sunflowers start to flower, because one of the biggest pests with sunflowers is head moth. And a lot of people have to spray sunflowers once or twice for head moth so it doesn't make the heads fall off. But typically when we're doing this and with this companion rotation, we see very little insect pressure on the sunflowers. Crop diversity drives soil biological diversity, and the biological diversity drives the system. And so that's what we're seeing. We've got legumes in here. I've got mung beans and cowpeas and the clover and the other peas putting nitrogen into the system. I've got these flowering plants bringing the beneficial insects. You can see the nodulation on the bean plant there. All kinds of bees. We had all kinds of bees flying around all of this. So if you've got, if you've got people that are keeping bees around, tell them to bring all their bees over when you're doing this, because not only they don't have to just wait for the sunflowers. They've got the buckwheat flowering early, and there's a lot of these plants have what's called extrafloral nectaries, where there's actually nectar coming out of the leaf nodes, and it doesn't just have to be a bloom in order for those insects to be able to do their job. Beautiful. If you plant this, you'll have all kinds of people wanting to come out and take pictures in it. This is what it looks like at harvest time. So these sunflowers are mature, they're ready to harvest. But looking down below here, I still have lots of nice green. I'm doing lots of good things for my soil, and once I harvest this, I could even turn cattle out and graze this as well. So that's an example of how we can take that principle of wanting to add this diversity. I can employ that, but still get my cash crop, still get some grazing, and still have my soil benefits as well. So is that going to work for you? I think it probably could in this area. I don't see any reason why it wouldn't. Is it going to be easy to do? Not necessarily. You got to find a place to sell sunflowers. There's all these other things. You got to have equipment to harvest it and different things like that. So it may not be the easiest thing to do, but agronomically, there's no reason why that wouldn't work here for you. So, and I'm not saying you have to do that, but think outside the box a little bit, beyond just grazing, 1 or 2 or 3 crops that you're used to in your area. Number 5 thing that I've learned: cover-ups and competition are good things. Again, we want to cover the ground. I've already told you the story behind these pictures, but I just like looking at how bad of a farmer my neighbor is every now and again, so I put it in there again. He's actually a lot better now. I think he's sold the land to somebody else, but we just have to keep the ground covered up, because when we do that, we get a lot of benefits. So Rolf Derpsch, who's kind of the godfather of the soil health movement in Brazil, in Paraguay, says almost all advantages of the no-till system come from the permanent cover of the soil, and only a few of them come from not tilling the soil. So in other words, what he's saying is when we're in no-till, it's good to not till, because structurally it does a lot of bad things to the soil. But the most important, the worst thing that happens when you till is that you lose your residue, and now your soil is bare, and all kinds of bad things happen when it's bare. So again, this is what we would like it to look like when we plant our corn. You don't see anything moved here, because the only thing that has gone through there was a set of double disc openers. And this residue just folds right back on top of it, and I've got complete coverage there yet. So some people were asking me earlier about cereal rye and corn, and so I'm going to address that here in these slides, because it is much easier. If you've never done cover crops, the absolute easiest thing to do is to plant cereal rye after corn, let that grow as long as you're comfortable doing it, and plant soybeans into that cereal rye. That's about as easy as it gets. You don't have to really change much else in your system to do that, because there's very little negative impact of the cereal rye on the soybeans. Really easy to do, widely done. You can find tons of information about doing that. Planting cereal rye into your soybean stubble and then coming back with corn the next year is more difficult. And some people say, it's kind of widely put out there, well, cereal rye is allelopathic to corn. And while it can affect the corn, I don't think it's really alleliopathy. Alleliopathy means that it's a chemical barrier to preventing the other crop from growing. And so true alleliopathy will not allow that next crop to germinate. And there probably is some documentation, but it's incredibly rare. Paul Yassa, great researcher at the University of Nebraska, he has tried multiple times to do this on purpose, planting corn into all kinds of rye, and he's never really seen the effect. What we see when you plant corn into cereal rye and then your corn turns yellow, which is very common, happens a lot, is not alleliopathy, it's simply nutrient tie-up. It's the fact that cereal rye is so good, so very good, because it has a massive root system at sequestering nitrogen. It will pull all the nitrogen out of your soil, which it has soybeans. Not only does it not hurt the beans, but it actually helps them because it forces those beans to nodulate early and often, and then as that rye decomposes, it will release that later. But ahead of corn, that could be a bad thing, especially if you put your nitrogen out there ahead of time and your rye all of a sudden sucks all that up. Cereal rye that gets 5 feet tall, if it has a lot of nitrogen out there, it can easily have sucked up 150 pounds of nitrogen. So if you put your nitrogen out there early and you have cereal rye and you let it get big and then you plant your corn and add no more nitrogen and you have yellow corn, guess what? It's not the cereal rye's fault that you have yellow corn, it's your fault because you didn't manage it properly. The rye is doing the job that you hired it to do, protect the soil, build the biology, but also to sequester nutrients and nitrogen and not let them get away. It's doing its job, you just have to know how to do it. So I've got a series of pictures here that's going to show this. So here is some corn planted into rye stubble. This was actually, we did some experimentation here where we had a field where the most of it we sprayed the rye out a week before we planted corn, but some of it we sprayed the rye out 3 weeks after we planted the corn. And this picture was taken in the middle of August, and you can still see, look at how much stubble residue I still have there. I mean, that's really impressive to have that much clear out to the middle of August. Now, we don't typically do this because it does require more moisture, and I think I have some pictures here. Well, yeah, so when we spray the rye out ahead of time, it starts breaking down much quicker. So if I'm spraying my rye out and it's only 2 feet tall, I've got good weed suppression early on, and I'll show you some weed suppression pictures, but I don't have the weed suppression later in the season because cover crops are going to give you weed suppressive benefits from 2 different mechanisms. One is going to be simply from a flat competition standpoint. I was talking to somebody at the break here about this earlier. Before we started using cover crops, our #1 weed issue on our farm was mare's tail. Mare's tail was resistant to just about everything, hard to kill it, and it just grew like a banshee out of the gate because there was nothing else growing, because it starts growing in March, it's a winter annual, starts growing in that cool season, and if you're not out there spraying it when it's really small, you couldn't hardly kill the stupid stuff. And so you ended up spraying earlier than what you wanted because you had to spray before your other weeds were coming up, and then you had to come back and spray again. And so you just ended up spraying multiple times to try to kill the stuff. Cereal rye is incredibly effective at controlling mare's tail. Once we started using cereal rye as a cover crop, it will control 99% plus of your mare's tail without doing anything else. Mare's tail is a very poor competitor. It's just that in March, there's nothing else out there for it to compete against. And here's a picture of that. So this is cover crop cereal rye right here. And if you were to go and look into that, there is 0 mare's tail there at all. This is corn. The corn is coming up here. So this is taken May 11th. So the corn is coming up. So this was operator error, also known as unintended research. We just either drove wide or didn't get the drill down in time, and so at the end of the field there was just this gap where the cereal rye cover crop did not get planted. But look at all the mare's tail coming up. There's no shortage of weed bank mare's tail in here. There's just simply no mare's tail over here where this rye is. And that was not a heavy rate of rye. That was 40 or 50 pounds of cereal rye. 40 or 50 pounds of rye will control mare's tail because it just outcompetes it. 40 or 50 pounds of rye, especially when it's terminated at an earlier stage, will not give you late season weed control, because the late season weed control doesn't come from competition, it just comes from a smothering effect. You've got to keep the sunlight from hitting the soil, because that's what triggers weeds to grow. A weed seed's not going to grow if it doesn't see sunlight and know that it can take off and grow. So as long as you can keep it shaded, you're not going to see those weeds emerge. But look at all this bare soil. I mean, we think that we're pretty good no-tillers, but yet even in a good no-till system, we have such active biology now, it is just consuming residue so fast that we have, if we don't keep this kind of stuff growing to add this carbon and the residue, I end up with way too much bare soil. And this, you see here where I have good residue, not a lot of mare's tail, but where I have any kind of gaps in the residue cover, lots of mare's tail coming. So we're using this because covering up your soil is, obviously it helps prevent erosion. It's also preventing a heck of a lot of weed growth there as well. Here's another example. This field split half and half. Cereal rye cover crop here, no cover crop over here. Look at how many weeds are in this area. I mean, that's just solid weeds. There's a few over here. It's not going to be perfect. It's not going to be 100%. But man, it made a difference. And this is before any herbicide applications. He's obviously going to have to come through here and spray this. But it made a tremendous difference in holding back the weeds simply where he had this cereal rye cover crop. So if you don't do anything else with cover crops and you're wondering where to start, by all means start with following up your corn crop with cereal rye. Relatively inexpensive, it's easy to do. You plant it with a grain drill and then plant beans into that the next year. It's just the easiest way to have some successes. Here's another picture. This is out in western Kansas where this ground is fallow and they're going to be going to wheat the next year. So instead of just doing chemical fallow like they're doing here, they planted a cover crop, oats, peas, barley, things like that. They let it grow up. This picture is probably taken around the middle of June. They spray that cover crop out before any of those species make seed, and then they just let it set, and it holds the weeds back pretty well, whereas over here, where nothing had been done, all kinds of weeds coming on that. So here's some other pictures from our farm. This was Elbon cereal rye, planted September 20th. We grazed it in the early spring, and then we came in May 20th, and we drilled soybeans. So this was planted. We got the corn off a little early, September 20th. We planted the rye right away. We had the combine and the air seeder in the field at the same time. Had enough growth that we were able to graze it, and then we put our soybeans out here. This is what it looked like in the middle of August. Okay, how many weeds do you think is coming in here? None. And the only spray, now at this time we didn't have a great roller, so we had kind of a homemade roller. So we drilled, we rolled it down after we drilled just to kind of get the plant as flat to the ground as we could to allow sunlight to come down to the plants. We knew that we hadn't killed all the rye, so we did come through with a herbicide pass after all of that to terminate whatever rye wasn't dead. And that was the only herbicide application this field got the whole year. And we didn't need it because we had this much residue still in the middle of August. And that's tremendous. If you can have that kind of residue, you're not going to have an issue. Here's another benefit. And this is one that we hadn't really realized, and there's more research being done on this right now. But think about this. Remember I showed you the pie chart of the atmosphere. The little sliver that's CO2, 4/100ths of 1%, is how much CO2 is in the atmosphere. Your crops have to pull all their carbon out of that fraction. But guess what? When I have a situation like this, and these are 15-inch beans, so I was spreading it apart so you can see this. So I had pretty well complete canopy. When you have a situation where you have heavy residue cover on the ground and a full green crop canopy over the top, as this residue is decomposing and breaking down, and it is, because this was irrigated, or even if it wasn't irrigated, anytime it rains, the biology is active, it's breaking that down. Part of the decomposition process is a CO2 release. Okay, those bugs are expiring CO2. The process of degradation releases CO2. The scientists are finding now that when you have a closed canopy over the top of this, even though it's not sealed, this crop is going to soak up more carbon dioxide from below than it does from above. So now, not only, what happens is because the crop does not have to work as hard, because this CO2 release here is higher concentration than 4/100ths of 1%. And if you know anything about greenhouse production, to increase production in greenhouses, what do they do with the CO2? They pump more in. They have higher concentrations of CO2 because they know it leads to increased yield, increased efficiency. So what we see with this is we see these beans grow faster and they will yield more because they're picking up more carbon from down here, and in addition to what they're getting out of the atmosphere, so they can grow faster, they can grow bigger, and they'll yield more because I've got extra carbon. Plus, and I don't know if any of these carbon programs will be able to measure this or give you credit for this, but any carbon that I'm intercepting from down below before it ever gets to the atmosphere, well, that's the best sequestration possible. You know, one way to get it out of the atmosphere is to never let it go up there in the first place. So again, it's the importance of having my decomposition staged to when my plant needs it. If I had come in and sprayed this out when this rye was a foot tall, well, that's all decomposed in the first 3 weeks. Or if I had 5 foot tall rye and I tilled it in, that's breaking down so fast by the time I till it in, all that CO2 is fluxed up into the atmosphere before my soybean plants are big enough to help capture any of that. So it can be a very effective strategy there. Here's what those beans look like when, from the top. Again, no weeds. That big canopy or that big cover was down here. And just to show you that there is weed pressure in this field, from where I took this picture right here, I just simply pivoted around and I took this picture. The road's right here. This is the end rows, where you drive the grain cart and the combine, and it's always compacted. And the cover crop just didn't grow as well because of the compacted soil. And this is the amount of Palmer amaranth coming in this area because I simply did not have as much cereal rye residue there to hold that back. Makes a big difference. Number 6, cattle love the salad bar. Cattle love the salad bar. Let me go back because I'm not sure I completely answered the question of corn and cereal rye. So if you're seeing or hearing about people that have yellow corn following cereal rye, it's all about the nitrogen. And so if you're going to be doing this, don't be doing fall anhydrous, okay? Because your cereal rye will send you a thank you note and say, I appreciate all that, I've got it all tied up for you now. And don't be putting don't be streaming liquid on out there in March or April because if you think about it, corn really doesn't need a lot of its nitrogen until probably June at the earliest. And that cereal rye is actively growing, it's going to get it first. So you just really have to figure out a way to delay your nitrogen application closer to the time that the corn needs it and away from the time where your cereal rye is actively growing. And in fact, I recommend and I like to see people put a little bit of nitrogen in furrow with their starter if you can, if you got the right nitrogen that doesn't burn the seeds. Because if you have an actively growing cereal rye crop, it's really good at what it does, and there's going to be very little nitrogen available in your soil. So you just have to manage your way around it, and when you can figure out how to do that, you can plant corn in a cereal rye, and it can be very effective. Now, is it better to have a crop like hairy vetch or winter peas that's producing nitrogen and not taking it? Yeah, it is. It sure is. Or a mix of the two? Absolutely it is. And we're doing a lot of different research, and what we've seen is we can get by with as little as 20 or 30 pounds of cereal rye along with 10 or 15 pounds of hairy vetch and produce about 140 pounds of nitrogen if we're willing to let that cover crop grow out to the end of May up in our area and plant our corn the first part of June. Are we willing to do that? We haven't decided yet. We're willing to try it. Are we willing to switch everything over? I don't know. Maybe. Again, I reference Rick Clark because we just were with him for 2 days. He's doing this on 5,000 acres. He says, I will never ever plant corn in April again. And it's not because April planted corn always did bad for him when he was a conventional farmer. It's simply because in an organic no-till system like he's in, if he plants it in April, his cover crops have not had time to do the job that he needs them to do to get the benefits that he needs to have to replace the technology he's no longer using. But when he is willing to wait, and he's gone from growing 112, 15-day corn to a lot of 95 to 105-day corn, and he's okay giving up a little bit of yield because his inputs are next to nothing. And he's selling it for organic prices. So the question on is rye allelopathic to corn, I think the answer is no, but it certainly requires a high level of management to make it work right. Don't start there. If you've never done cover crops before, I do not recommend planting rye into soybeans and following it into corn. Plant your rye into your corn, follow it with soybeans. That's easy. Get your feet a little wet, get a little confident with it. Learn all you can. Think about how you're going to apply your nitrogen, because that's going to be the key to making that system work. Or think about doing more than just straight cereal rye cover crop too. Mix in some hairy vetch, mix in some winter peas, do some things like that, and not just do straight rye. Straight rye is going to be the best weed control. It is not going to be the best for the corn crop from a nutrient standpoint. Okay, cattle love the salad bar. I don't have a lot of time to talk a lot about grazing, and quite frankly, I'm not the guy to ask about grazing. If you've got questions about grazing cover crops, these two boys from Oklahoma back here will have far more information than I do. But what we've seen, and this is another thing that we saw when we did our experiments in 2008, when we had those moisture sensors. When we did that, we learned three things. Number one, we learned that the mixtures were much more efficient with using water than monocultures were. Number two, we learned that cattle did extraordinarily well grazing these mixes. I mean, they came off those summer mixes fat. They were probably too fat for bred cows. We should have had stockers out there. And number three, what we learned, it's hard to find that seed, and that's why we decided to start green cover seed in 2009. Because of the 30 things that we found, we had to get them from about 10 different places. And because we saw the power of the mix from the very beginning, our company has been set up with diverse mixes as the emphasis from the very beginning. And so we have very few pre-made mixes because we want to work with each individual to design the mix that has the best chance of working. Properly managed livestock is a great way to extend the benefits of cover crops. And again, Russ showed some pictures and talked a little bit about some of the success. Jimmy's got some great success stories. You know, there's just, you know, person after person can show you great data, you know, of getting feedlot-like gains on grazing cattle on these cover crops. But they have to be managed properly. If you turn cattle out and you're just, you know, like Russ said, what did you say? It was the Columbus method of grazing. You know, you send them out there and then later you rediscover them. Yeah, that's not going to help your soil health. Whether you're doing that in a pasture or in a crop field, that's probably going to send you backwards. You're better off not doing cattle than to do them wrong. And I like this quote. Grazing is an art, using the same tools and supplies but getting different results because of the creativity and the intuition of the artist. In grazing, there really is an art to it of understanding forages and understanding ground cover and understanding how animal utilization. So if you want more information about that, there's a lot better people than me. So number 7, remember to focus on your most important crop. You know, in the midst of, you know, farming is a high stress, you know, intense time, labor type setting, and running a cover crop seed business is the same. I think it's important that we don't lose focus on our most important crop. Most of us, that's going to be our family, it's going to be our community, it's going to be the people that we're with and around. So make sure that you focus on that. This is my family, my wife right here. We've got 7 children and a whole bunch of grandkids. This is from a couple years ago when we took a little trip down to the Gulf Shores of Alabama. So I want to close with just a little story I call the Tale of Two Fields. Instead of the Tale of Two Cities, this is the Tale of Two Fields, because this happened with our field and one right next to it, and I just think it really sums up a lot of what we have seen, it validates, to me anyway, it validated what we were doing versus what our neighbor's doing. So this is about 4 or 5 years ago. Our neighbor had grown corn and we were growing soybeans. So he harvested his corn and we were harvesting soybeans right across the fence line from each other. Now you would think that he, with all this corn, and these are both irrigated fields, so water's not an issue. You would think that the amount of residue that he should have from 200 plus bushel of corn, and he should have all kinds of residue out there, right? And from soybeans, they don't have much residue. I'm going to have bare soil come spring, right? Well, my neighbor comes in, he shreds it, he rakes it, he bales it, and he hauls it off to the feedlot. And I don't know, he was probably getting $30 a bale or something for this, which he probably thought was a pretty good deal. Well, knowing what I know now, I should have bought all his bales for $30 because there's probably more nutrients in that. While he was baling it, we were in here drilling a cover crop on it. And while the winds came up and blew all of his away, so this is the next spring, you can see soybeans trying to come up. Where is all that residue from all that corn? Well, it's at the feedlot. And what he couldn't get with the baler, the winds blew away. And so now instead of having awesome ground cover from all that corn, he's got nothing. And he's got soybeans that are struggling to get out of the ground because it's rained. You see how flat this ground is. It got blown and then the rain pounded it and it just crusted it up, and these soybeans are struggling to come up in these rows. And all you see is nubs out here because everything else is either washed or blown away. And this is completely flat ground, and this is 100% no-till. 100% no-till. Okay? No-till with no cover is no good. So just because you're no-tilling doesn't mean you're doing it well. Here's what our field looked like. So we planted soybeans, planted the cover crop into that, the cover crop, and we had a relatively mild winter. We had all kinds of things. So crimson clover blooming, I've got hairy vetch blooming, I had winter barley survive, I've got winter peas over here. They're not quite blooming yet, but they're looking good. And we have planted this already. This has been planted. You can see right here where the planter row unit went. So this has been planted, but I haven't rolled it down yet to terminate it. But it's okay. That corn's going to take a little while to get out of the ground. I was not in a super hurry. It's so pretty to look at. I didn't want to kill it any sooner than I had to. But look at the amount of life that I have here compared to what he's got going here. He's the one that should have had the residue cover, and I should have had bare soil. But because of management choices that we made, I've got this. I've got life, ladybug on a pea leaf right there, with corn already planted in the field. And this is what it looked like on the edge. So I've got corn that's going to be growing up through this. And yes, there could be nitrogen tie-up, but we didn't put any nitrogen on ahead of time. We'll come put that on later. We'll put that on later after this is decomposing and drying down. He's got beans just struggling to come up because it's just been pounded and beat on and all that residue removed. And that's, he didn't use cover crops, but I do like to close. My friend Steve Groff has this saying, and I love it. It says, cover crops will make a good farmer better and a bad farmer worse. And that doesn't mean if you have troubles using cover crops, you're a bad farmer. What it means is if you're not prepared to add additional management to your system in order to use cover crops, there's a pretty good chance the cover crops aren't going to help you. Or at least they're not going to do what you're hoping and thinking that they'll do. You have to be prepared to add the extra management in. And because you're here learning how to do some of that management, I think that you're going to be okay. Do I have any other slides? If that's okay, that's the last one. So I have a question that somebody had came up to me earlier, and I'll address this, and then we may have time to take a few more. It says, can you speak to the fact of injecting P and K for better yields or for better use? I think that the Hefty brothers maybe were talking about injecting P and K into the soil. You know, my response to that is if you are applying P and K, because they don't move nearly as readily as sulfur and nitrogen, injecting them into the soil probably is going to be better than just surface applying them. Do you need the P and K? it depends on how you're farming. Again, the phosphorus is one of the hardest things to get out of the soil. It's one of the things that the soil contains the most of, but it is tied up so tightly in the mineral form that plants just cannot get it. And so biologically, can you get it released? Yes, you can. Will it be enough? Depends on what you're doing. Buckwheat, which we saw in the companion planting of the sunflowers, buckwheat is a very interesting plant. Most all plants will be good hosts for mycorrhizal fungi. The mycorrhizae that I showed you earlier, mycorrhizae is one of the strongest ways to get phosphorus out of your soil. It's very efficient at pulling phosphorus out. Almost all plants will host this arbuscular mycorrhizae fungi. The exceptions are everything in the brassica family, so radishes, turnips, collards, rapeseed, mustards. None of those host arbuscular mycorrhizae fungi. As a plant family, they just don't. They don't kill it, they're just not a host plant for it. So that's why I would never want to see you plant a solid field of just radishes or just turnips, because if you do have mycorrhizae out there and you plant a solid field of brassicas, you're going to severely hurt your populations because they have no host and they have no food source now. Throw in some oats or some rye or some barley or peas, something that the mycorrhizae can live on to keep them going. But the other plant that does not allow mycorrhizae to associate with it for whatever reason is buckwheat. And so buckwheat, in order to get phosphorus out of the soil, has had to develop ways to do that, and buckwheat roots will secrete different acids, different than other plants. They're very strong acids that come out of those plant roots, and it allows buckwheat to actually get phosphorus out of the soil that other plants can't touch. And it does that partially because it doesn't have mycorrhizal associations. So buckwheat will get the phosphorus that it needs out of the soil, so if you have buckwheat in your cover crop, and then that buckwheat dies, you will have more phosphorus available for the following crop than what you did if you didn't have buckwheat. And so I've got organic farmers, because buckwheat grows really fast, it's really good at weed control, it's relatively inexpensive and cheap to plant. They'll plant buckwheat, let it grow for 6 weeks and terminate it, and then come in with another crop because that's their phosphorus source for the next crop that they're doing. It was weed control, and now it's their phosphorus, and now they'll move on to the next cover crop. So will injecting P and K help have a better utilization? It probably will, like I say, as opposed to spreading it on top. But I think that you can decrease the amount of P and the amount of K that you're using if you ramp up your biology. Version 7 of the resource guide that you have in your books here, there's a really good article in there from Dr. Christine Jones. It's called The Phosphorus Paradox, and she'll talk about how you can release phosphorus naturally through farming differently through biology. In version 8, there's an article in there from Dr. Christine Jones about, it's called Nitrogen, the Double-Edged Sword. Again, talking about nitrogen utilization, how putting nitrogen on both hurts and helps your crops, and how it's much better if we can get it from more natural sources. We've got webinars. We did 4 webinars with Dr. Jones. They're probably the best webinars we've ever done. They're completely free to watch. They're on our YouTube channel. Lots of people have said those are some of the best content that they've ever seen on a webinar. So I would encourage you to go to YouTube, just search for Green Cover Seed, Christine Jones webinar, and we'll bring that up. And then it's not in our book yet, but I will have it in next year. We did a webinar with Richard Mulvaney and Dr. Saeed Khan from the University of Illinois. Dr. Mulvaney talked about nitrogen utilization, and it's really interesting because he works for a land-grant institution, and he completely throws the land-grant institutions under the bus about nitrogen recommendations they've been making, how they're doing the testing and all that. He basically is saying it's not accurate whatsoever. There's better ways to do it. Very, very interesting. But the part I found incredibly interesting, his colleague, Saeed Khan, he talked about potassium and how potassium moves from the inorganic to the organic portion much more readily. Basically, and I can't speak to this, we've never applied potassium fertilizer on our soils, ever. Our soil tests have just never called for it. We have very high potassium soils. We've never had to even worry about that. But what he's saying is that the state of Illinois alone is wasting $60 to $80 million a year putting potassium on their fields that is not needed because people don't understand how potassium functions. And so if you are putting potassium fertilizer on your soils, I'm not saying that you'll be able to completely eliminate it, but I'm saying you should watch that webinar because it's got some really interesting things in there. And if you have more questions, send me an email. They've sent me a couple of additional papers that they've written that I can send to you if you're interested in a deeper dive on that. So putting this in the soil is probably a good idea if you're applying it. Changing your biology to where maybe not eliminate, but probably reduce would be even better. So are we up against the break, or do you want to take a couple more questions?
We might save the questions for the end.
Okay.
Yeah.
Okay, we'll save the questions. Thank you, everybody. Appreciate it.